Good evening, ladies and gentlemen. It's 3:02 in India, so we've decided to start the webinar. This is a series of webinars that Quintype is planning, the first of which is Behind the Uptime. This is our webinar around infra and DevOps. The speakers for today are our Head of Engineering, Himani Jain, and our Head of DevOps, Rahul Joseph. We hope to have a lot of questions from our customers. Mind you, this is a customer-only event. There's only Quintype customers on this webinar. To ask questions, to the bottom right of your screen, there is a 9-dot button. When you click on this button, you will see an option for Q&A. Feel free to add your questions while the webinar progresses. We have reserved the last 15 minutes for Q&A in this webinar. Let's get started. Over to you, Himani.
Thanks, Aditya. And good afternoon, everyone. And thank you all for joining us. Today, we are going to take you behind the scenes of Quintype's publishing infrastructure. This webinar is about sharing real-world solutions to the real-world problems. We'll show you actual production metrics and the lessons we have learned from running infrastructure for over 350 plus newsrooms. So here's what we are going to cover in the next 45 minutes. We'll start with talking about the scale we operate at. Then we'll be giving you an architecture overview of our cloud-native microservices-based architecture. We'll share our resilience philosophy, which is the guiding principle behind all our decisions. And from there, Rahul will take over for deep dives. He'll start with explaining DDoS and how we are able to handle 45 plus attacks in the last year. Then about zero downtime deployments, auto scaling and self-healing, how with Kubernetes we are able to scale automatically and recover without human intervention. Then it will be about smart scaling strategy, like our multi-layer caching approach. Post that, at the end, we will be talking about war story from the AWS outage which we had last month, and post that we'll talk about the Cloudflare outage which happened just yesterday. At the end, Q&A. Cool. Let's get started. Before we dive into how we do things, I want to give you a sense of the scale we are operating at. It will help us to understand why resilience matters. So let's look at the numbers. So we serve over 5 billion requests every month. And our platform has published 2.5 billion stories in the last year. Our 95th percentile API response time is 80 milliseconds, which means 95 out of 100 API calls return in under 80 milliseconds, even under heavy load. And we maintain 99.95 uptime guarantees. That is around 4 hours of allowable downtime in a year. We have mitigated 45 plus DDoS attacks in the last 1 year alone. And yes, we continuously keep upgrading ourselves. We have done 200 plus code changes in the last 1 year in production, which is around 4 times a week. So yeah, just to repeat, these aren't some aspirational numbers. This is what we measured last year in our production environments. So when we talk about resilience, we aren't talking theory. We are talking about systems that very much work under real pressure. Yeah. So now, let me give a glimpse of high-level architecture that has made all of this possible. So what we are looking at is a cloud-native, distributed microservices-based architecture. Everything here is designed for resilience. On the left, we see 2 types of users. Readers who access our front-end websites, and editors using the CMS. And notice the 2 different traffic flows, the greenish arrows and the bluer ones. So they are separate paths. basically separate load balancers, total isolation of the two concerns. The readers and editors concerns are isolated throughout the flow. It goes through our CDN edge layer. So basically that's Cloudflare. This is where we do the DDoS protection, the WAF, the CDN caching, and rate limiting. So this is basically our first line of defense. And from there, the traffic hits our front-end applications, which are like the reader-facing websites. And they run inside containerized microservices on Kubernetes. So all of our services are orchestrated by Kubernetes. So below that is the API cache layer. This is quite critical. It sits between the front-end and the backend APIs. It caches the responses and dramatically reduces the load on our backend servers. Then we have our API services. This is where all the business logic lies. And each of these services has its own, like they are in their own Kubernetes pods with their independent scaling policies, which means like if one is affected, the other continues to operate independently. And yeah, similarly for editors flow, the traffic goes directly to our CMS application, which is the Bolt CMS, the page builder, the website builder we have, the syndication systems, etc. And yeah, towards the right is the caching layer, which is where we cache the data from the data layer. Cool. So this entire architecture is designed with the goal of redundancy at every single layer. Like if one pod fails, Kubernetes restarts it. If one cache layer misses, there is another one behind it. And if one microservice goes down, the others continue to serve requests. So no single point of failure. And it's not just us saying our architecture is super solid. AWS has verified it. We have completed well-architected review, the AWS WAR. And we work closely with AWS through their foundational technical review program, which is also called AWS FTR, where their solution architects review our architecture for best practices. Yeah. So yeah, this is what is behind the battle-tested infrastructure. Yep. So everything we build at Quintype is guided by this philosophy that infrastructure should be visible when it works, resilient when challenged. We understand that publishing is a 24/7, 365 thing. Our readers don't care that it's 3 a.m. or it's Diwali or it's New Year's Eve. They expect the site to work always and seamlessly. Similarly, editors don't like to be interrupted due to technical issues. Like it doesn't matter if it's midnight or election results which are searching the traffic. They just expect we should handle it without disrupting the editorial workflow. And we also believe that you shouldn't have to think about us when things are going well. So yes, that's the invisible part in the philosophy. But yes, the reality is bad days do happen and we need to be prepared for it. We believe our architecture should expect these bad days. Like instead of hoping it won't happen, it's better to be prepared for it, because sometimes a small code change can lead to a break in the production, or a DDoS attack where like coordinated requests come in to bring our system down, or it could be a viral content which is causing the unexpected load. We need to be prepared for it. Similarly, AWS downtime or a Cloudflare downtime, where services we don't control and we can't fix them, but we are still expected to just be up. So these are some examples of bad days, and these aren't some hypothetical scenarios. Like in the last year itself, we have dealt with all of these and multiple times. And the difference is that we build assuming they will happen, we design such that we are resilient to these. That's our whole philosophy. Cool. So, yep. Now, I hope I was able to set the context about a scale, the scale at which we operate, the philosophy which we follow, and the challenges which come on the way. I would take a pause. I would like to remind the folks on call to keep posting questions in the Q&A section. We'll answer them towards the end. I'm going to hand things over to Rahul. Rahul is going to take us one step deeper into how we achieve resilience in practice. He'll show us the DDoS matrices from real attacks. He'll talk about the self-healing systems, the blueprint deployments, the auto scaling, and yes, finally, he'll walk us through the war stories from the previous month. So over to you, Rahul.
Thanks a lot, Himani. Hi, everyone. I think the context has been set up pretty well, so we can dive right in. First, I'd like to talk about how we handle DDoS attacks and traffic spikes. First, I will give a quick intro on what DDoS is. DDoS, or distributed denial of service, is when attackers flood our servers with massive amounts of fake traffic. These will be from multiple sources, could be from multiple regions, could be from multiple IPs. And all of this has a single objective: to overwhelm our infrastructure and make the website unavailable to legit users. Think of it like thousands of people simultaneously trying to jam a single doorway so that nobody can go through. Now, this is something that we deal with regularly. This is business as usual for us. We have dealt with over 45 DDoS attacks in the last year alone. The graphic on the left shows you one such example from September of this year, where the spike was of hundreds of millions of requests. We do get DDoS attacks in billions of requests as well. So as you would expect, our first line of defense is at the edge with Cloudflare. We use edge filtering, which blocks the malicious traffic before it even reaches our servers. That alone would not be able to identify every single DDoS out there. So we have set up multiple different rate limiting rules for specific APIs, endpoints, based on host, etc., to ensure that the traffic, if the traffic is surging by an abnormal amount, they are rate limited. Now, along with this, we have anomaly alerts. We monitor on real time for alerts. These could be unusual spikes in 404s. It could be a huge increase in the number of cache misses that is typical of a DDoS attack. Or it could be just an increase in failed responses and a spike in error rate. Now, all of these alerts are listened in closely by our on-call team, with not just DevOps, but including developers who are on a rotational shift. Now, from the hundreds of millions of requests you saw there, what I've done here is I've just filtered out the ones that were forbidden, which were blocked by Cloudflare. And you can still see that although majority, around 95% of the attack traffic was blocked, the specific host that was getting targeted by the DDoS attack went from 500 requests to 1.45 million requests in a matter of minutes. So it is still a lot of traffic that is coming through. But this is expected, and we are always prepared for it. When an anomaly detection fires an alert, my team gets notified in real time. And this is when we, within minutes, we deploy custom firewall rules to block certain URL patterns that we see based on the attacker. We also sometimes enable capture challenges, which will ensure only known bots like your Google bot, Facebook bot, etc., and humans can go through. So The combination of the automated plus the manual manual effort results in around 95%, 95% of malicious traffic blocked at the edge, plus 99%, 99.9% uptime during attacks as well. Now that we have covered DDoS in itself, I wanted to dive in a little deeper into our Kubernetes infrastructure. So we roll out changes constantly. Like Himani mentioned, we have over 200 deployments in the last year. We do not put any sort of limits on the number of deployments. Developers are free to deploy as they would like, but we cannot afford a single second of downtime during these updates. So that is why we utilize some features in Kubernetes to ensure our uptime here. Now, for those who are unfamiliar with Kubernetes, I just want to explain what pods mean. A pod is basically the smallest deployable unit in our infrastructure. Think of it like a container that runs your application code. And each pod will be specific to a specific type of service as well. So like Himani mentioned, we have different microservices running. And each of those services would have multiple pods running at any specific point in time to ensure that we have redundancy and load distribution. Now, for the deployments itself, we use something called blue-green deployments. Here's how it works. So you can see the blue pods and the green pods in the graphic over there. When we deploy a new version, new pods are created with updated code. Now, before the old pods are terminated, we always have a readiness probe that makes sure the new pods are actually healthy and ready to accept the traffic coming in. Only after we ensure that the pods are ready for that, we do bring down the older pods one by one. Now, bringing them down one by one is a rolling update process that we follow to ensure that the desired replica count that is required to handle your traffic is always there. So the impact of this is that there is 0 seconds of downtime during all deployments. And if something does go wrong, we also have the option to roll back the deployment within 30 seconds. Now, apart from deployments, we need to also deployments are when there are changes to our infrastructure, but we also need to ensure that pods that are running continue to run. We want to ensure that they are healthy at all times. So the beauty of a well-configured Kubernetes cluster is that it constantly monitors the health of these pods. We have health checks to specific paths that are always constantly monitored. So our system basically is monitoring itself. If a pod becomes unresponsive, it is automatically restarted. Like you can see in the graphic there, when the liveness probe fails, the Kubernetes cluster automatically restarts the pod. If a service crashes, a fresh instance replaces it instantaneously. And memory leaks of any sort get contained with memory limits that we have played before it cascades into larger problems. And if there are any sort of crash loops, basically where a pod keeps restarting itself, the system will detect it and escalate it to our team. What this does is it basically gives us 95% automated recovery. There is no requirement to manually log into cluster and restart any service to fix itself. For example, people who have EC2 instances running or virtual machines running, we've always, including me, I felt the pain when we had to just log in to make sure the VM is restarted just to get things up and running again. Now, apart from this, our infrastructure also needs to handle the unpredictable traffic patterns that we talked about, like the viral news and seepage and DDoS attacks. So, and publishing is inherently spiky traffic, where a breaking news story can send your traffic up through the roof in minutes, right? So that's where auto scaling comes in, where a traffic spike, when traffic spikes, the system is expanding automatically. When it's a slow news day, our resources scale down to to reduce costs. And we are always performance optimized with a lot of headroom to spare. There are specific thresholds that we have set, including but not limited to CPU and memory, which when it reaches our threshold, like you can see in the graphic in the left, scales up the pods as soon as when we need them. Now, just to show how immediate it is, these are screenshots at the same time from our monitoring tool, which shows the spike in CPU immediately resulting in the number of replicas going up. And as soon as things quiet down, us scaling back to the minimum number of pods available. This helps us make sure that we can handle greater than 10 times the traffic spikes and automates the optimization required for our cluster. Meanwhile, if you have any questions up until now, do add them to the quick Q&A. Adi will curate the questions and we would answer it all together at the end. So now one more critical piece of our resilience strategy is the smart caching that we have. Himani did talk about this in detail, so I'd remind you again about the architecture that we have, where when one cache fails, we have another. It starts with the CDN cache at the forefront at the edge, after which the front-end apps again has an API caching layer before the API services added by the application cache that is there in memory. Now, along with this, what we do have is a stale if error configuration set across caching layers that returns the stale response, which is an outdated response, even if there is multiple errors that you see. The logic there is that we would rather have the end users see the older content rather than seeing no content at all. And these errors that I'm talking about are when we have those kind of outages like AWS outage or Cloudflare outages. Now, we also have an emergency override option. This is something that we very rarely use. It is not something that we use at all. But we do have the capability to increase the cache times for all content only for those specific scenarios where there are some kind of large outages, global outages, or maybe a maintenance window that we have already planned for, where the caching is, we want to serve the cached content for a longer amount of time. Now, we talked a lot about different scenarios, but we would like to bring about actual real world scenarios, specifically ones that have been that kept us occupied for the last 2 months. Now, large outages like this haven't happened for AWS or Cloudflare for at least since 2019, but we are having a combination of them right now. So there was an AWS outage which the world knew about on October 20th. Not just publishing and media space, but everyone from Snapchat to McDonald's to smart beds in homes got affected by this downtime. And we saw that this was a major outage on the US East 1 zone, which majority of services use. And they were affecting EC2 instances, the SQS, S3, and database services. And we got to know about this before any sort of indication, thanks to our developer teams who were trying to deploy some new code. And Docker Hub, which is what we use to store container images, started failing. So we couldn't get new images. So what we immediately did, without being aware that it was just AWS downtime was that we froze all deployments and made sure that our image pull policy is set to, if not present, to reuse the images that we already have in our servers. Then we figured out that our purging mechanisms, although our publishing was working fine, our purging mechanisms were impacted. So the latest stories were not showing up in the front end. We set up fallback mechanisms for these for the SQS, Amazon SQS queuing mechanism that we use. And we moved our API caching layer on the fly. Like we talked about, our API caching layer is on AWS and it is running on a pod. But we moved that API caching to the Cloudflare CDN edge to ensure that we have better caching. And this basically resulted in 350 plus newsrooms staying online during a global cloud failure, with readers having near zero downtime during this phase. Now, this is what resilient infrastructure looks like in practice. It's not perfect, but it is prepared. We are not invisible, but we are incredibly hard to take down. Now, the second outage that I talked about is the Cloudflare outage, which together happening just yesterday. I had to spend some time to create these slides just a couple of hours ago because we had this incident yesterday, but it seemed like a good talking point for us to add here. Multiple sites again, like ChatGPT, Claude, Twitter, etc., were down yesterday as well because of the Cloudflare outage. It really felt like a lot of our favorite websites are like keep going down these days. But yeah. So the Cloudflare outage itself lasted for about 7 to 8 hours. For us internally, it only impacted the images and static assets that we use. Our host, our primary host domains that were hosted on Cloudflare were unaffected. So you could still see your site load, but mostly without the images shown. So this impact itself was intermittent. So we were seeing that after around half an hour, the intermittent images issue actually went down and we were able to see all images load, which we thought was an indication that things are recovering. But then things again went worse for the second spike. Now, this is the outage image that is shared by Cloudflare today in their blog, which was related, which we could relate to because we saw the similar pattern yesterday while we were working on this. Now, like I said, our primary content delivery was intact. Our image pipeline was compromised. Our image transformations were failing, resizing, compression of images, all of those were not working. Since the images loaded briefly after 30 minutes, we were still awaiting to see if things were resolved, but again, things started going down. Images were intermittently not available. That is when we tested out our alternate image CDN, which we have configured, which is Gumlet. Now, Gumlet, although it is relying on AWS CloudFront behind the hood, it seemed like they are somewhere using some sort of Cloudflare DNS services for making things work. Now, this in turn made the Gumlet image CDN unavailable as well. That is where we took a critical decision that we are going to bypass image transformations. We are directly going to serve it from a CloudFront distribution set up on our AWS without the resizing. Now, what that basically meant was all content was accessible. There is no optimization, no resizing. The raw images were sent to origin, but the global outage that was lasted over 5+ hours was less than 1 hour for our newsrooms clients. Now, this did come at a cost. We had significantly higher bandwidth usage because we were serving full-sized unoptimized image, but Quintype absorbed all the additional cost. You would get to see that you have not been charged for any sort of images bandwidth during the said 5 hours. And that's the commitment that we make to our clients. When there is a crisis, we don't pass the financial burden to you. So this is again another point in what I mean by resilience. It's not just about having backups. It's about having the ability to make quick decisions that we adapt even when our backups fail. It's not the most elegant solution at all times, but it's the one that keeps our clients online. And with that, I'd like to conclude what I had to cover today, which I'll pass on to Adi for the Q&A.
To anyone who's missed what we called out in the beginning, to ask questions, there is a 9-dot button to the bottom right of your screen. If you click on that, you'd be able to post your questions. Rahul, Himani, there is one question already. Perhaps you could get started with that, and then we take more questions as they come.
Yep.
So the question was, are you considering any alternatives to Cloudflare after yesterday's events? Himani, are you going to take that?
Yep, I can take that. Yes, so every outage is a learning opportunity for us, and we are continuously evaluating our architecture. Like with such opportunities, we have been able to amend things in our architecture. So we definitely are open to evaluating and changing things up. But that said, Cloudflare's track record is still excellent. Like yesterday was an exception, not a rule. So we are still more focused on like ensuring our fallback mechanisms work effectively. Because like it could be any CDN. So ability to switch to the fallbacks effectively is what we are more focused on. And but yeah, also keeping in mind the cost which comes in with the like having multi-CDN options, we have to think about that as well. So it's something we closely monitor and evaluate. But yes, that's what it is now.
Thank you, Himani. We haven't received any other questions. There are a lot of familiar faces on this call. I'm sure you guys have questions. Please feel free to post your questions. Chris has a question. Being an image-centric site, we often use large images. Is it advisable to consider image optimization prior to upload instead of relying only on server-side optimization? Who will be responding here? Rahul, Himani?
Yeah, I can take that. The reason it is a good point and a valid question. The reason we do not do that is because we want to enable you to be upload images and immediately publish those at real time. We are having numerous discussions about if we can do it on this on the server side itself in another backup CDN other than Gumlet, because it is quite evident that Gumlet is now also Cloudflare dependent. But it works well for us. The image optimization itself happens on the fly, and it is cached at Cloudflare. So we would not be looking at doing it in the server. We'll not be doing it on the server. We will only be doing it on the fly, but we are looking at alternatives for our alternate CDN that we can use for such scenarios.
There's another question. This is from Priya. Is there any alert system that helps you flag these threats or outages? And how do you communicate this to your clients?
Yeah, thanks, Priya, for that question. I'll take that. We do have an alert system at different levels. Cloudflare did notify us yesterday about the outage. We were alerted. In terms of how we communicate this to our clients, we use the status page that we have, the status.quintype.com, which is what you can subscribe to, so you're immediately aware of in terms of there is an outage. As soon as Cloudflare flagged the downtime, we did flag the downtime in our status page as well. Yeah, so that's how you can commonly get to know.
Priya, also the status page is something that you should get all team members to subscribe to. We typically have at least 1 or 2 people from each publisher who subscribe to the status page, but status page does send out alerts every time we have even a minor issue, and you will be able to track the progress as well. Roderick Allen has a question. Can customers get per site performance uptime reports or dashboards?
Adi, you want to say a bit more on that in terms of maybe the superset dashboards that we have?
Sure. Roderick, yes, it is possible. Quite a few of our customers do have dashboards where they can monitor their site performance. When you say site performance, are you referring specifically to your uptime only, or are you talking about overall performance of the website? There are dashboards available. We can have your CSM talk to you and make more data available to you if that's what you require. But it is possible, yes. So the short answer is yes, there is data available and there are dashboards possible. Thank you, Roderick. We do have time for maybe 2 more questions. Right. We hope that this session was of value to you. We're happy to see a lot of familiar faces on this call today. Thank you so much for sparing your time and joining this webinar. We hope to have more such webinars on a monthly basis going forward. Thank you for joining this call today, and we hope to see you again soon. Good evening.